So, get this. What if a mind's biggest weakness was actually the source of its greatest strength? It sounds like a paradox, right? Well, today, we're diving into this really fascinating cognitive profile that's packed with incredible gifts, but also some really surprising challenges, all happening at the very same time.
Right, so this is what experts call a twice exceptional mind. And the name says it all, really. It's exceptional because of some kind of remarkable talent, and also exceptional because there's a learning challenge that comes along for the ride.
And this right here. This is the central mystery we're going to try and unravel today. You've got this paradox of a brain that can build these huge, complex worlds of thought, just amazing structures, and yet it can stumble when you just ask it to follow a simple step-by-step line. I mean, how is that even possible? Okay, so to get our heads around this, we've got to start by looking at this mind's hidden superpower. And believe it or not, it all begins with this beautiful idea that kind of sits right at the crossroads of math and art. Yeah, I bet a lot of you have seen tessellations before, right? Think of those mind-bending drawings by M.C. Escher, where all the lizards or birds or whatever just fit together perfectly with no gaps. Super cool to look at. But as it turns out, these patterns are way, way more than just pretty pictures. And this is a total reframe. We're not talking about art anymore. We're talking about powerful, super precise tools that scientists use in things like geometry and physics to map out and solve really complex problems. The whole point is creating these complete, gapless systems. Okay, and that brings us right back to the superpower. It's this way of thinking called 3D VT. That's three-dimensional visual thinking. So just imagine the brain is acting like both an artist and a mathematician. It's creating its own incredibly complex, perfectly fitting tessellations. But instead of using shapes, it's using knowledge, symbols, and concepts. So you can see the parallel here, right? Just like a mathematician uses shapes to tile a floor perfectly, this cognitive style builds a whole, like a complete geometry of understanding. It's this multi-dimensional map of knowledge where every single piece just clicks into place perfectly. But, and this is a big but, here comes the twist. This unbelievable strength in building these amazing, complex structures, it comes with a very specific and honestly, a pretty surprising challenge. And let's be super clear, this weakness has nothing to do with intelligence. Not at all. It's more like a bottleneck when it comes to processing stuff in a simple one thing after another linear flow. You know, it's the kind of thing you might see with dyscalculia, which is a difficulty with numbers. It's really about the speed of pulling up symbols or words in the right order. So boom, there it is. That's the core conflict. You've got this mind that's like a master architect, right? It's brilliant at building this giant, intricate palace of knowledge. But then it struggles with something that seems so simple, like just walking a straight line to the front door. That's the rapid sequential part. So what happens then? How does a brain like this even function? Well, it doesn't just break. It adapts, and it creates this incredibly elegant workaround to make up for that weakness with linear stuff. This grand strategy has a pretty fancy name, tabular coherence maintenance. But what it really means is that the brain's number one job is to protect the wholeness of its mental picture, that cognitive tessellation. It's always checking, integrating new info, and self-correcting to make sure the entire map stays complete and, makes sense. And what's really cool is that this isn't just happening randomly. It's like there's a dedicated team of brain regions all working together. You've got the planner, which handles the big, abstract ideas. Then there's the architect, which arranges all the tiles in space. And finally, you have the storyteller, which gives the whole pattern meaning and emotional weight. They're all working in concert to build and maintain this amazing mental structure. Okay, hang on, because this is where our story about the human brain takes a totally unexpected and really fascinating leap. We're about to jump into the world of cutting-edge AI. Get this. It turns out that to get our most advanced AIs to actually reason, to really think and not just spit out answers, we have to teach them to do the exact same thing. We have to teach them to build their own coherent, step-by-step mental models first. Sounds familiar, right? It's just like the brain we've been talking about. The technique they use for this is called the format reward. And it's a really clever little rule. In training, you don't just give the AI a cookie for getting the right answer. No. You reward it for showing its work, for building out that logical step-by-step path from the question to the final conclusion. You're literally rewarding it for being coherent. And this whole approach is absolutely key. It basically forces the AI to adopt a reasoning first, answer later model. And by doing that, it's pretty much replicating that geometry of meaning that the twice exceptional mind builds so naturally. It's all about making sure the logic is solid before it even thinks about giving an answer. So here's a peek under the hood of how that works. The AI generates these chains of thought, these reasoning paths. It explores a few different ways to get to an answer, and this is just like the brain's self-correcting system, it compares those different paths and basically gives a thumbs up to the most logical one. It's simulating that human drive for coherence by making its thinking visible and then tweaking it until it's perfect.
So where does that leave us? I mean, think about it. We started this whole journey looking at what seemed like a deficit, a weakness. But it turns out that very same deficit gives rise to this incredible compensatory superpower, a way of thinking that's so powerful, so effective, that we are literally trying to program it into our most advanced artificial intelligence. It really makes you wonder, doesn't it? What other superpowers are we completely overlooking in minds that just happen to work a little differently?